Section 11.5, integration by substitution. Remember from the previous section where we've started on the idea of substitution, replace the awkward bits. So the bits that have a higher power, the parts that are in the denominator, the bits that are under the square root, so that's a weird power. And very often in those questions, you will have the substitution given, but it's not always the case. So you need to be confident in understanding which part of your expression can be substituted. Okay, now here actually this question can be resolved in two different ways. So they suggested to use in the first instance the substitution u equals 2x plus 5, and in the second instance u to the power of u squared is equal to x plus 5. So let's see, as soon as you've got the substitution, you should always differentiate it. So that will go to 2. And as I've done it before, I like to do it very slowly and multiply it by dx. Although it's not a fraction, we're going to use it in the method to make it behave like fraction. So before I carry on, I could see, well, I've got dx, so yeah, now I'm going to divide it by 2. So dx can be replaced with a half du. So I've got the replacement for that. Good news, that's going to be half du. Now I've got the replacement for that. That's going to be square root of u. Now, do I have the replacement for that part? And the answer is you always look for this work in this work. And yes, you do, because you can rearrange this one to obtain the expression for x. So x is going to be equal to u minus 5 over 2. So substituting it into this, you will have u minus 5 over 2 multiplied by u square rooted multiplied by a half du. There you go. So let's expand those u's. I'm going to take those two halves and make them into a quarter at the front of the integral. So you've got u minus 5 multiplied by u to the power of a half. I've got to prepare it for integration the same way you did it last year. So it's u to the power of 3 over 2 minus 5 u to the power of a half du. Now I'm going to integrate. So add 1 to the power, divide by that power, and then this one, add 1 to the power, so it's 3 over 2, divide by that power. Okay, I'm going to use the space on this side and we'll do the second part somewhere else. Okay, so we've got to tidy it up, and then we have to substitute instead of u 2x plus 5. So a quarter, on the calculator you can literally do a quarter divided by 5 over 2, but I'm just going to do it a quarter. Dividing by 5 over 2 makes it into timesing, but 2/5, and then this one makes it timesing but by 2 over 3, so it's minus 5 times 2/3 u to the power of 3 over 2. Okay, so it's going to be a quarter times 2/5, so it's 2 over 20. I'm going to go back to my substitution. Actually, let's go back to that. I'll show you how to factorize it as well. And then over here, if you multiply a quarter by this, it's going to be 10 over 3 times a quarter. So it's 10 over 12. Okay, so over here, you can factorize the common brackets. Now, it's quite a tricky thing to realize how that can be factorized, but this is like having if that's the same power, you can take the biggest amount of 2x plus 5 is this one, so 2x plus 5 to the power of 3 over 2, so you can take it out. So it's going to be 2x plus 5 to the power of 3 over 2 can be taken out. Now I'll deal with the coefficients in a minute, but you can simplify these into 1/10. And then you will be left, if you imagine dividing it by 2x plus 5 to the power of 3 over 2, then if you subtract the powers, you'll be left with 2x plus 5 to the power of 1. And then you've got 5 over 6 left. And we just tidy up this bracket, okay? So it's going to be 2x plus 5 over 10 minus 5 over 6. You can bring it to the common denominator, which here is going to be 30. So if you times that by 3 and that by 5. I am taking every step really slowly because this is what students find difficult. So this one here is going to be times by 3 and this one by 5. So you have 2x times 3, 6x plus 15 minus 25 over 30. And then this one here is going to be 6x minus 10 over 30. Now you can divide by 2, and you've got 15, so you can take the 1/15 out, and you will have 2x plus 5 to the power of 3 over 2, and then 3x minus 5. There you go. That is quite a challenging. In the book, they literally stopped at this stage, but they obviously cancelled these coefficients. So you've got 1/10 here and 5, 6 over here. So you could have stopped here, but if you're interested in how to simplify further, then you can carry on over here. Right, let's try and squeeze in the answer to this part B over here. So imagine if you've got the substitution u squared is equal to 2x plus 5. So you've got to differentiate it. Now one way of differentiating is to make x the subject, okay? So u squared minus 5 over 2 is equal to x, and then you can differentiate. So you will have dx du, and it's going to be a half of u squared will go to 2 over 2, so 2u over 2, and then minus 5 over 2 goes to 0, so that will be u. So dx can be replaced with u du. Another way of differentiating it is using implicit differentiation. And that means you will have 2u du dx, and then you will have 2 dividing by 2 and moving x across. It takes you to the result straight away. So now I look at my question. My question had, let me just write it again. So I could see that dx can be substituted with u du. I could see that square root of 2x plus 5, that's a square root of u squared, so that will become u. And then x, you rearrange that part. So rearranging it, you have x is equal to, oh, we've already done it over here. So that can be replacing x. So my integral will be, my x is going to be u squared minus 5 over 2. My square root of u squared will be u, and dx is u du. So over here, let's take a half out, and I've got u squared here multiplied by u squared, so u to the power 4, and then minus 5u squared. Add 1 to the power, divide by that power. So this way, actually, if you were to factorize it, it might make sense to factorize it first and then do the substituting if you wish. We can have a go at taking the u cubed out, and we can actually make it into the common denominator of 15. There you go. So you will have a half times 15, so it's 1/30. And then over here you will have 15 u to the power 5, sorry, 3u to the power 5, minus, over here you are going to have 25u cubed. And now take the u cubed out. Now I'll have to go on to the next page. Okay, so let's copy that down. You've got u cubed over 30, and in brackets we had 3u squared minus 25. But remember, u squared was 2x plus 5. So 3u squared minus 25 is going to be 3 times 2x plus 5 minus 25. So that is going to be 6x plus 15 minus 25. So 6x minus 10, which is 2 lots of 3x minus 5. I recognize that from before. Now what about u cubed? Well, if u squared is 2x plus 5, then u must be equal to square root of 2x plus 5, or 2x plus 5 to the power of a half. So u cubed is 2x plus 5 to the power of 3 over 2, because you've got the power of a half raised to the power of 3. It becomes 3 over 2. So our integral will become, that is 2x plus 5 to the power of 3 over 2 over 30, and then that bracket simplified to 2 lots of 3x minus 5. That cancels, and you're left with 1 over 15, 2x plus 5 to the power of 3 over 2 multiplied by 3x minus 5. Again, I've chosen to factorize it because you might be forced to do it, but if you are not forced to do it, when you get to this stage here, maybe there, if you didn't even need to take 1/30 out, then you do your substituting. Just take care with substituting when you've got u squared. You need to make sure what u is, that it's that expression to the power of a half. Okay, so this, I believe, yeah, we need to do more examples. So example 13, you've got another 2 examples to complete. So they're giving you the substitution, u is equal to sine x plus 1. I normally actually write my substitutions on this side and then do all the work to do with the substitution altogether on the right hand side. So du dx is the replacement for, it's cos x. So du is cos x dx. Remember, don't just go straight away, dx is du over cos x. You could, but just before you do that, think, have I got cos x dx? And the answer is yes. So these two are worth du. So they will be replaced with du. Now, have I got the replacement for 1 plus sine x? Yes, I have. That's going to be u cubed. Have I got the replacement for sine x? Well, again, I have, because sine x can be replaced with u minus 1. Let's put these together carefully. So remember, cos x dx, that will be du at the end. Sine x is u minus 1, and this one is u cubed. Let's expand it, prepare it for integration. Add 1 to the power, divide by that power, so it's 1/5 of u to the power of 5 minus 1/4 u to the power of 4 plus c. Going back to our, again, this one could be factorized. Let's just check if they bothered with, they are not bothered with factorizing, so this time I'll skip it. So it's sine x plus 1 to the power of 5 over 5 minus sine x plus 1 to the power of 4 over 4 plus c. Okay, example 14, it's tells you it's a show that question. Okay, in this type of question, you just need to do it a few times to realize what's going on, because they are not telling you what substitution to use. So I normally say substitute for the awkward bit in the denominator, but this time it won't work because there's no parts of its derivative, which would be minus 2x, anywhere in the numerator. So they give you a hint. So you're going to try and use the substitution u equals to arc sine x. So we need to differentiate this function. So what is arc sine? Well, that's sine inverse. Before you get to that part and apply the inverse, you must have had sine u is equal to x. So I'm going to differentiate x with respect to u to get dx du is equal to cos u. Okay, so dx is equal to cos u du. Now I've got dx, so that tells me I can replace it with cos u du. That's good. Okay, so I've got the replacement for half of my integral, the end bit. Now I need to find the replacement for 1 minus x squared square rooted. So 1 minus x squared can be written as 1 minus sine squared u. Yeah, I was just trying to think. And that is cos squared u. So square root of that must be cos u. So I have got the replacement for 1 minus x squared. So I'm ready, cos u. And that one was cos u du. So I can just rewrite my integral. So this is going to be 1 over cos u and then times by cos u du. The cos nicely cancel and you are integrating 1, which is u, which is arc sine x. Job done. Okay, we'll come back to example 15 in an hour. Of course, you could multiply all out and then integrate each term, but it would be definitely not efficient if the power was bigger than 3. So we're going to substitute x plus 1 with u. As soon as you've decided on your substitution, differentiate it. So du, if you split it, can be replaced with dx. So over here we've got dx, that will go to du. We've got this, that will become u cubed. And what about x? Well, there's always time to glance at what you're doing with your substitution. You rearrange it, that is u minus 1. So you've got all the replacement. So your integral, I'll deal with the limits in a minute. X is u minus 1 times u cubed du. So we are going to expand it, u to the power 4 minus u cubed du. And then you add 1 to the power and divide by that power. Now over here, what we do, if we do have limits, we are going to substitute limits, but at the moment they are x's. So we need to find what u is when x is equal to 0 and what u is when x is equal to 2. So these are our new limits. So changing limits will give us u2 is, we're going to substitute into this 2 plus 1, which is 3. So that will become 3. And u of 0 is going to be 0 plus 1, which is 1. So we don't need to go back to x's, we can just sub those new limits. So it's 3 to the power 5 over 5 minus 3 to the power 4 over 4. Subtract 1 to the power 5 over 5 minus 1 to the power 4 over 4. So Working it out, it gives us 48.4 minus 20. I don't know why that's 20 in there. I'm just copying right now because I don't have a calculator. I'll deal with the limits in a minute. X is u minus 1 times u cubed du. So we are going to expand it, u to the power 4 minus u cubed du. And then you add 1 to the power and divide by that power. Now over here, what we do, if we do have limits, we are going to substitute limits, but at the moment they are x's. So we need to find what u is when x is equal to 0 and what u is when x is equal to 2. So these are our new limits. So changing limits will give us u2 is, we're going to substitute into this 2 plus 1, which is 3, so that will become 3, and u of 0 is going to be 0 plus 1, which is 1. So we don't need to go back to x's, we can just sub those new limits. So it's 3 to the power 5 over 5 minus 3 to the power 4 over 4. Subtract 1 to the power 5 over 5 minus 1 to the power 4 over 4. So working it out, it gives us 48.4 minus 20. I don't know why that's 20 in there. I'm just copying right now because I don't have a calculator. Well, let's just check those limits in. So if you've got 3 to the power of 5 divided by 5 minus 3 to the power of 4, sorry, divided by 4, yeah, that's 28.35, and that's clearly going to be 0.2 minus 0.25, that's going to be minus 0.05, so that adding them together gives us 28.4. So in the textbook the workings out are incorrect. Good. Let's have a look at example B. So over here, if you imagine this one here is 1 plus sine x to the power of a half. So the awkward one is this one. So we are going to replace this bracket with u. Differentiate it. You're going to get cos x. So split du is equal to cos x dx. Now have a little glance at what's going on within the question. Have I got cos x dx? If I do, that's good news. That whole thing can be replaced with du. If I don't, then you carry on, make dx the subject, and then substitute. 1 plus sine x, the bit under the square root to the power of a half, can be written as u to the power of a half. So our integral is going to be u to the power of a half du. We'll change the limits in a second. Let's integrate it. Add 1 to the power, divide by that power. Now the limits are going to be whatever u you will get when x is 0, and whatever u you're going to get when x is pi over 2. So u0 is going to be 1 plus sine 0. That gives me 1. U of pi over 2 is 1 plus sine pi over 2. That's 1 plus 1, giving us 2. Let's sub the limits. So you have 2 to the power of 3 over 2 over 3 over 2 minus, let's put 0, that's just going to be 0, but always show, even though it is 0, that you are taking account of that. So let's pop it into the calculator. You're going to have, if it's in the exact form, I wonder whether the calculator will cope with 3 over 2 without us doing any extra work. Yeah, it gives you as a decimal. So flip the fraction, it's 2/3 times, this is going to be 2 to the power of 1 times 2 to the power of a half. So if you're forced to give your answer in exact form, you need to be extra careful. So this is going to be 4/3 root 2. Okay, let's just double check. Oh, right, just realized that I've made a mistake with that. That's not going to be 0 at all, because the lower limit was 1 and I've accidentally put, or stupidly put 0 in. So let me just actually sort this lower limit out again. That's going to be 1 to the power of 3 over 2 over 3 over 2. So I need to take away 2/3. So take away 2/3, you can leave your answer like this, or if you factorize 2/3 out, you'll have 2 root 2 minus 1 left. That's better. Now, if you know, we're all humans, we make mistakes. You can always check your answer using your integral function. So you do, you need to be in radians. I am in radians, so you need to write it down as cos x, which is here, the alpha, and then square root, we are going to put 1 plus sine x, close brackets. Let's get to the end, and there's the limit, 0. So you copy down the question as, I think I've already done that one, as it appears in the book. There you go. Now the answer is 1.2189, and what is this? 2/3. So is 2/3 the same? So 2 over 3 followed by 2 root 2 minus 1. 1 to, yeah, that's correct. Okay, so you can have a go at exercise 11E.